All right, can you hear me right? Okay. So, I'm going to skip the courtesy slides that I usually put. You all know me, so let's get to the meat. We all love HTTP in Node. That's usually probably the mostly used part of Node because people install a web server or a web client and so forth. And the question is that which HTTP are you? As we all know, there are only three possible choices for HTTP, even though we are talking about a 25-year-old protocol. We get 1.1, which is the last version of the initial protocol, and by far is the mostly used. We also have HTTP 2, which was an improvement to bring SPD to improve the network usage. And then we have the 3, which is the new one, which was developed on top of Quick to solve all the TCP problems by switching to UDP, which opened the room to other problems, but that's another topic. What is the current situation in Node? We have implementation of all of 3. We have HTTP 1.1, which is stable, and same for HTTP 2. Then we have HTTP 3, for which a PR is along the way, and we all have to apologize to James again because we haven't reviewed his PR, so his PR is still pending review and such. But anyway, let's focus on what we are here for today. The current parser for HTTP1 in Node is LLHTTP, which was created by Fedor in 2019, and this is the default in Node since Node 12, replacing HTTP parser. It works by being a state-based HTTP parser based on LLParse, which transpile TypeScript to C. Now, what's wrong with LLHTTP? It's very hard to debug and release because you have to transpile, release, and if you want to debug issue in the transpiled version, it's pretty hard. It also has a problem about the backward compatibility. LLHTTP aims to also support HTTP 09 or 1.0, which have been obsoleted like 20 years ago, so there's absolutely no point in supporting such old protocols. And it has several flags for leniency, which open the door for a lot of smuggling attacks, vector-based attack, and all other things of attacks you can think of HTTP1. So it's very not a good idea on the security side to have such a lot of edge cases to manage and handle CVEs and security release and so forth. Is usually not a good idea. Which brings to a very simple question. Do we have a solution for that? Can we do something about it? We can start fresh. We just take LHTTP, take the good, and replace with something else. And that's why I'm going to introduce you today Milo, which originally was the name of that little Tamiya squirrel, which is a Japanese squirrel type that my then girlfriend and now wife owned several years ago. I'm talking like 15 years ago. So I named after that little guy. And let me drop the bomb so you all happy and you can start shooting at me. It's written in Rust. It's not C, it's not C++, it's Rust. I found this language when writing Milo very flexible and very performant, as we will see in a bit, to achieve this task. And fun fact, apart from very stupid side projects, before writing Milo, I didn't know Rust. I have no idea how the language works completely. But I'm not here to start a language flame, so be cool, please. Just be cool. Anyway, like I was saying, I don't want to throw the good part of LLHTTP away, because Fedor wrote a very nice parser, and I want to give any kudos to him. And LLHTTP deeply inspires Milo, and I kept most of his architecture. I just overly simplified it. For instance, we still have a state machine which is able to parse the same language, but with 33 states rather than 80, so it's way simpler to debug. And I was able to find a way, exploiting a lot the procedural macros that Rust support, to write states in a very understandable way, even after the transpilation, which I will show you in a bit. Because the idea is that procedural macros in Rust are actually Rust code that runs. So in theory, for instance, you could download data while compiling a macro and embed that data inside the final executed code. I mean, I don't know why you might want to do that, but it's technically possible. So there are limitless possibilities on this. Now, how is that? As I said, it's all in the macros. Let's clarify what are the perks here. First of all, the Rust macro system is not evaluated at build time, but at compile time, which means that any bad things that you do to achieve your compiled code, any unperformant compilation of macros will be forgotten because the compiled code will only contain the new Rust statements that you generate. Everything that brought to that statement is forgotten and you don't really care. As I just said, as long as you return Rust code, everything is permitted. And the idea is that there is a specific tool which can easily help you to debug this issue, because you can, before even getting to the build time, you can do cargo expand via the cargo-expand utility, and you get to see what your code is transpiled to when compiled. I mean, as usual, example of words more than 1,000 words. So on the left-hand side, you can see a definition of a state in Milo. This is basically the state that says once you reach the end of a chunk when you do the transfer encoding, if you get a CRLF sequence, then you reset your chunk size and you go to another state to receive a new chunk. Otherwise, if you have at least two characters which you are not expecting, you fail. Otherwise, there is the last state, which is the catch-all. Say if you don't have at least 2 characters, you just suspend the execution of the parser and you wait for more data to arrive. That's it. That's the state. On the right-hand side, you see the compiled version. You can easily recognize how the left-hand side matches to the right-hand side. There is a definition of a function, which is state chunk end, which is named after the first parameter. Match data, as you can imagine, is the data that is currently being analyzed. And then you have the sequence of byte in the line 6, which are /r/n, and unused one in the line 10, which you compare to the otherwise. That's easy. This thing applies to all the possible states in Milo, which means that you can run cargo expand to the entire parser, and you can see what your state gets compiled to. Similarly, you could use different macro to generate eventually a state diagram. For instance, I haven't tried yet, but it should be doable. Because in theory, I'm not restricted to output Rust code, but I could output, for instance, YAML code probably. So generate a graph out of it. Now comes to another question. What about resources? How much data does Milo use? Once again, I chose this to follow the same approach of LLHTTP, so I'm not copying anything. I'm doing a no-copy eager parsing of input data. The only exception, there is just one exception, differently from LLHTTP, if you give me enough bytes and I don't consume all of them, I batch them, the missing bytes, in a separate buffer. And then when you give me the next chunk of data, I will prevent it. So you don't have to count how many bytes I actually consume or not in case of partial messages. So it's just convenience for the user DX. Final remark. Milo is strict, period. There are no leniency flags, and I only support HTTP 1.1 per the very last standard, so which is 1910 and 1912. I don't support the 7230 and I don't support the 2616 standards, only the very latest one. So we get the latest standard and we don't have to worry about compatibility. Realistically speaking, I know that in the future user will probably ask to add the leniency flags, but for now, by design, I don't have them. And let's see where it leads us. Now, this is Milo in action. This is Rust code. Pretty easy to follow in a way. You create a new parser. You set some callbacks that always have the same signature, no matter if they receive data or not. It's always a parser, a data, and the size of data that you're receiving. And you can do whatever you want with it. Now, on line 20, you might notice that I'm passing a pointer and a length, which is weird in Rust, but because I want to have a common API for Rust and C++, because in C++ it will be the same. And this is the output. If you ever execute the previous code, do cargo run, You got a position, an event, the status, another name, value, and the body. I mean, this was just a very stupid example. You can do much more complex stuff. And I hear you, your internal self whining, but Node uses C++. How do we use this in Node? Can we use this in Node? That's the C++ workflow. We can easily use that because we need just a separate tool, which is cbind-gen, which is supported by Mozilla, which is a tool that out of Rust code generates valid C or C++ header. Basically, it extracts the public interface and generates an header for you without having to write a single line of code. And it only needs a very small, like less than 10 lines of a TOML file in order to configure the extraction. That's it. On the other side, Rust and its toolchain via Cargo already supports outputting a static library, so a .a file in the Unix world. And this file can be statically included within Node when compiling, and that's why you embed Rust within Node. Rust, Milo, and Rust inherently within Node. And this is a C++ file. As you can see, it's kind of similar to the previous one. So once again, you create a parser, you set a message, and you create, in this case, I just set the onData callback. There are some casting because Rust use unsigned char for the strings, while C++ usually use the char, but it's just about casting. It's not an issue because it never goes on the negative side of chars, so it's not really an issue. And then you just do Milo parse, and you do parser, interpret cast, you pass the message, and the length. So similar structure as the Rust code. And this is actually already working in Node. I have a branch of Node that already uses Milo for both HTTP server, HTTP client, and the inspector socket as well. So I replaced LLHTTP everywhere it was actually used within Node. And this is how you get to compile that little executable. So you basically just prepend libmilo.a in the compilation line. You execute the example, and you get the body as well in C++. Now, it comes out of common sense that if you have this working in C++, it is working within Node. And that's actually what I did. And that's Milo. These are the performances. On the left-hand side, you have autocannon test using LLHTTP. On the right-hand side, you have Milo. As you can see, at the moment, I'm lagging by between 2 and 5% compared to Milo. But don't forget one crucial step. I don't know Rust. So I got to the same performance of LLHTTP without knowing Rust, so probably there's room for improvement. I can probably improve the code a lot, and I already have some crazy ideas I can try. Which brings to the very last thing. What's next for Milo? First of all, shame on me, there is zero documentation because I just focus on get this thing ready by today, so I completely forgot the documentation step, which is next thing I'm gonna do, promise. I'm on camera, so I have to appeal to this promise. Second, I want to at least match LLHTTP performances so we can replace LLHTTP in Node or eventually beat it because that's my final step. I need two things to be helped on this project. First of all, Rust validation. Somebody has to analyze the Rust code I have written and give me hints on what I've been doing. And second, have a real complete integration with Node. Because now I just focus on have this thing compile on my machine, which is on Mac Silicon. I have no idea how to, probably will be the same on Linux, but I have no idea, for instance, how to compile on Windows or on the other fancy architecture that we support. So for that, I need help from the build team or any team involved in linking libraries in Node. Last thing, one smart code just to enlighten our day. A person who never made a mistake, never tried anything new. So that's why I went for Milo. I want to challenge myself and also challenge Node to eventually be open to new languages to be included within the source code and in core. This was from Albert Einstein. That's it. Go for it. Shoot.
Is it a repo that's public?
Yep. I forgot the link. Damn it. You're right. So that's github.com/shogunpanda, which is my handle, /Milo. Okay. That's just public. And if you go to my fork of Node.js, there is also the branch with Milo on top. Yes.
What's your username again?
Shogun Panda. Wait a sec. This one, for your benefit. I forgot to link the Milo, you're right. Yes, Rafa, what's up?
So if I understand correctly, to use that library, we would need to rely on another library that will convert the Rust code to C++ to
No.
that library, right?
No, that's a different tool. You mean cbindgen?
Yeah.
Cbindgen will just scan the Rust code and generate a .h header, and that's it.
Yeah, but we need to do it for every release of Milo, right?
Yes, which is like what we already do for LLHTTP though.
Right.
Same thing, yeah.
And I wonder how reliable is this tool? Like, if that tool won't work for some reason, we lost the support to Node.js?
Automatically, yes, we can always generate that header by hand anyway.
Okay.
I mean, consider this thing. Nowadays, for LLHTTP, we rely on LLParse, which nobody is maintaining, including myself. I have no idea how LLParse works. And that one generates the HH header.
Yeah.
So we are in the same thing.
That's
The thing is,
I'm wondering if we pass by something similar using Milo, since it's Rust. And I mean, I'm just wondering. I think I have asked you already, but since you need to convert it to stuff library, why didn't you write directly on C++?
because the macro system is a mess. I don't want to transpile from Rust to C++ using the macro system because it would be overkill.
No, I meant like why you didn't write the Milo in C++ directly? Like it's something that you were avoiding using Rust, like memory safety or something?
No, it's because I don't have the... it would be very hard to write a statement like this in C. The match statement, there is nothing like that in C. That's probably the biggest thing I would bet. Because one thing that you're not noticing here, because it's completely hidden by Rust, is that data is an array of bytes basically. Think about this. Is a byte slice, so it's an array of bytes, and Rust is capable of doing capturing the spreading, so you can do a match x, y, z, k to the end. So it's a very powerful system that I don't think I can replace in C++.
So that's more for simplicity.
Yeah, because the thing is that I want to move away from LLHTTP because, as you know, it has a very steep curve for people that want to contribute. In fact, nobody's contributing to LLHTTP. I think like this, probably people can embrace pretty faster.
Okay.
That's the idea.
That makes sense.
Yep.
I think the biggest challenge is, like, as I understand it, this requires adding Rust as part of the node build.
No, because Milo is a separate repo. When I publish a release, like we already do nowadays, actually we do something different for LLHTTP, but when I build Milo on GitHub releases, I can release a .a file and .h file. Now the h file, of course, is shared.
.a files are, like, that's very specific to a platform.
I was about to finish that. I can release the h file, which is shared for all platforms, and a static library file for each platform involved. That's why I need help from the build team. And that way, when we download Milo, we download the static.
I think that's the problem, though. Like, does Rust even run on all of our platforms?
I checked the issue for most platforms we support. I mean,
Most isn't going to be
let me clarify. All the platform I could identify, it runs. I have to, once again, get help from the builders team to check which old platform we will support and check if Rust has support for it.
My one thought was, like, I know Rust will generate WASM. We already include WASM.
That's
Why not
yeah, yes.
WASM and then not like
That's another thing. I chose to avoid it at this moment because the thing is that I want to avoid C++ to WASM overhead because it's going to kill us. Which I probably also think is the reason why we do, for instance, we don't include WASM LLHTTP. So if we can manage to make the native one working, it will be better for performance. Otherwise, going back and forth on the C++ layer is going to kill us probably on the performance side. So if we see that Rust is working for all the platforms we support, which probably it is, because they support very fancy platforms, that should be fine. Consider that one thing I forgot to mention, Milo at build time, not runtime, but at build time, has no dependencies. So it's basically just playing with byte slice, which means that if Rust has at least tier 3 support for that platform, which is the lowest thing they support, Milo is going to run on it because it doesn't do any I/O. It just manages bytes memory. So that's pretty simple.
Yeah, I don't think we pull in any pre-compiled binaries like .a files.
No, but that's on me. That's on me.
But I don't think in Node we actually pull in any of those. We build things like that from scratch.
Most of the time, yes. If you can, for instance, for LLHTTP, yes, you do that.
LLHTTP, it generates a header file and C code.
Async code, yes.
File, right?
Yes, for LLHTTP, yes, because it's C++. But the thing is that, yes, if you stay on C and C++, yes, it's pretty simple. What I'm trying to, the thing is that with Milo, I'm also trying to explore if this is feasible for Node, because it opens ways to attract new collaborators, for instance, that are not proficient in C, but can bring other languages.
So I'm not arguing C.
Yeah, no, that's what I'm saying, yeah.
Like having to put in like the .a's.
Yep.
I think that's going to be a significant risk in terms of like, does your .a work on all different platforms?
Well,
Rust will generate awesome. We already do that.
yeah, the thing is that, consider like this, you already, with LLHTTP, you're not doing really any better on that because you don't bring the .a file, which is a compiled one. So you with the CI, you can easily verify whether it works or not.
You bring the C file. Right? So
Yep.
compiling from the source, at least there's a translation from the text definition. So I totally agree that.
That's impossible. Have you ever tried to read it, that file?
Great.
Yeah?
But in the end, like for our compile, we have a C file and an H file and it compiles
Yes.
on platforms. Across all of them, that's easy.
But
Like a .a file is very specific. Like those aren't necessarily meant to run across architectures or run
no. But the idea is that one of future plan will be I take any basically CPU or operating system that Node supports, and on GitHub I make sure I have a release for each of it. So you can only use the file that you actually need to compile.
But even wonder though, like across all OS variants, like
Yeah.
all the different Ubuntu's, are we going to have like 15 different .a files?
Yes. Yeah.
That doesn't seem very manageable.
Yes.
How is the dialogue going to be distributed? Is it going to be downloaded during the building process, or is it going to be checked into some sort of...
To be honest, I haven't talked about it, but we can see what's. I mean, probably I wouldn't download that build time. I would say since we already embed dependency in the deps folder, we embed, like Michael was saying, the H file and eventually the 15.a.dll, whatever the format is, probably, if it's feasible. Once again, it's just an experiment. We can see where it leads us. The parser is working anyway, so it's just a matter of the linking, which might be an issue.
Yeah, so is there a reason not to use WASM, which would be like one copy that runs on all?
No, that's what I told you, because to go from HTTP to WASM, you have to destructure the data, so you lose performance. It's just a matter of performance.
So it's because we're calling it C++.
Yeah, that's the biggest issue. Because otherwise, if it was not an issue of deserializing data, we probably would have moved the parser on the JavaScript layer a long time ago.
Do you have some idea about how big the data file is? If it's not too big, you can also check it into source.
I have to. That's another thing. I have to. Somebody from Rust must help me to trim it down. So far, I got to 4 megabytes for Linux. For macOS. Linux, I haven't. Sorry? Probably. Yeah. I mean, the debug version was 25 and the release version was 4, because in Rust there is a huge difference in what you include and not include, but that's another topic. 4 or 5 megabytes that's on macOS, so I don't know what is bringing on in macOS. Maybe on Linux might be less, on Windows might be more. I have to check case by case probably.
Yeah, I'm just wondering how we would distribute that because, as you said, you have inside dApps, possibly a folder called Milo with a bunch of .a across different platforms.
Yeah.
And when we build for distribution, we need to remove those other architectures, right?
No. That's not embedded as. It's not shipped as a separate file. Once you compile, it's embedded within Node, within the exec.
It will be embedded directly in the binary, right?
Yes. But you only link. Look at this one. Look at this line.
Basically, you just need a GIP file.
Yes. You look at this. For instance, there when I use clang, right? I included libmilo.a. Now let's assume it was libmilo-mac.a. Of course, you will not gonna consider the Windows one at all. We will just include the one that is actually needed. So in theory, the final binary will have just the needed one.
Right.
The distribution, the source code might be slightly bigger.
It would also be possible to include the source code in the project and then build
That's a yes. I mean, that's also a viable option. We can choose to embed the entire Milo, but we have to install Rust in every building machine we have. That's also a viable option for us if we want. But I was trying to avoid that because I don't want to enforce another language to be shipped within in order to build Node. That's why I went for the static. But if we see that this one is better for us because Milo in terms of source code is like literally 4 source file, very small, so that might be also viable. It's up to you.
I think that's, well, one thing that at least I do often is to manually compile dependencies. Like I perform the patch directly on the deps folder. So if that works, I go to the hook string and make a pull request.
yes.
Mm-hmm.
In the case of Milo, it won't work because I would need to fork primarily the Milo, generate the .a copy to the Node.js project and test it, right?
If you're updating Milo, it means that I already have a release on GitHub, which means I already have compiled using GitHub action.
We don't release, like I just want to play with Milo directly on Node.js to make some things happening. Like
Oh no, that's fine. You download,
for maintainability.
you fork Milo and you compile for you with your own machine. Just to make. I have a make file for that.
This is one of the points that we're talking about in the security team
Mhm.
about audit build of dependencies.
Mm-hmm.
So in this case, it would be much easier to have the source code already available for this specific reason because you can make changes directly into the deps folder,
Mhm.
compile it and test it, rather than to have a static library in your dependencies that is like a black box and you cannot do anything about it. So it's very hard to debug.
I mean, given that the source code is very small, nothing prohibits us from including both the source code and the static files in the deps folder for Milo, for instance. There's nothing that is preventing us from to do that.
Yeah, but that would be, so we need to include some hardware things and build things to make
There is a make file there is a make file you can use. If you have Rust installed locally and you go in the deps in the Milo folder and do make, it will build Milo for you, and that's it. So it's but once again, I mean, let me clarify. So far, I just focus on have this thing linkable to my node for my specific architecture on Mac, and I tried on Linux, which is probably and if I tried Windows is the most common. Now, of course, we have the exotic architecture that we need to support, which is, of course, is a requirement. How we then ship Milo with Node, I mean, in the source code, is completely up to discussion. I haven't even talked about it. I was just focusing on having something working to show you today, basically, for now. But it's completely open to improvement.
So currently, I can test if I want using our fork of Node the new.
Yes. If you go to my fork of Node, there is a Milo branch because other than changing just including Milo, I also have to change the Node.http parser CC file. Because of what I was referring to LLHTTP, I have to change to use Milo. And on my fork, there is also a local PR which also outlines the changes. If you want to take a look of what are the changes for in order to include Milo. I'm telling you in advance there are several test cases that I had to change because I dropped HTTP 1.0.
Okay, so that's just relying on constant RFC. So we imagine that there is no breaking change.
Say that again, sorry.
No breaking change if I include that in the Node.js 21, for instance.
No, there is only, I mean, one minor breaking change. The insecure HTTP parser option and CLI option is gone because it has no sense anymore. Since basically LLHTTP, Milo cannot be lenient. What's up?
No, I think we have talked about it in the security.
To remove it.
That's like,
Yeah, I already removed because basically there's no way to make Milo lenient. I want to actually one side note. Given the calls were completely different, there was no way to have Milo and LLHTTP working in the same repo. So we cannot support it at the same time, unless we completely duplicate the Node.http parser source code. because the callbacks have changed and they work in a different way.
Okay, so the pull request will be big.
No, it's not. It's just one CC file has changed. I added the deps folder, and most changes are in the test folder because I have to drop the one HTTP 1.0. But they're pretty self-contained. There is not really breaking there.
No, I meant the pull request in the Node.js to replace LLP to be
Just that file. This is one single file that has changed mostly. Outside of the test folder is only that file mostly. And the inspector socket, but much more smaller thing. Anything else before I drop? Anyway, if you want to see my slides online, they're online, and I will put the link somewhere if you want to take a look later with these for the Rust and C++ snippet eventually, if you want to take a look, play, or whatever. For the rest, all set. Thank you much, folks.